G'day again, back for question 15. So the amount of caffeine C in the human body decreases according to the equation dc dt equals minus 0.14 C, where C is in milligrams and T is time in seconds. There's a few parts, we're going to do one at a time. The first part, show that C equals A e to the minus 0.14 T is a solution to dc dt equals minus 0.14 C, where A is a constant. So this sort of thing is fairly straightforward and you should be used to doing this sort of question. To show that this is a solution, you don't actually start from there and go backwards and get to here as an answer. You actually start from here. Okay, so we're going to start from here and work backwards to prove that we've got that. So we're going to start from this. So C equals AE to the minus 0.14 T. Now we're going to differentiate it because we want to C to T. So if we differentiate this to C to T, differentiate anything with an E and this value comes in front, so we're going to get minus 0.14 AE to the minus 0.14 T. And now you're pretty much done. This value here is C. So you can say that this, therefore, to C to T equals minus 0.14 C. And you're done. G'day again. Back for parts 2, 3 and 4. Okay, so we've shown that when T equals 0, there are 130 milligrams of caffeine in Lee's body. Find the value of A. So this should be pretty straightforward. We're just going to use this formula and substitute in the numbers. Pretty easy. So T0, we're going to get a 0 up there and 130 where the C is. So for part 1, or part 2, sorry, we'll get 130 equals AE to the minus 0.14 multiplied by 0 because T is 0. Well, what's E to the 0? What's anything to the 0? 1. So this is A multiplied by 1, so therefore A equals 130. Okay, pretty straightforward and should be a very easy 1 mark. Part 3. Okay, part 3. What is the amount of caffeine in Lee's body after 7 hours? So again, substitute in and figure out what the amount is. And this should be pretty easy, just press it on your calculator. So we want to know what is C. We've got A, because that's 130, E to the minus 0.14, and we've got T, so T is 7. So it's that multiplied by 7. Punch that straight in your calculator and you get an answer, and it's only worth 1 mark. And what do we've got? We've got 48.79, or approximately 49 milligrams. Pretty straightforward again. Next one, the time taken, so that's worth 2 marks, is actually a few more steps. So in this next question we're going to do a little bit of log work. So part 4, time taken. So we know that this is going to halve. We're going to start off with 130 and we're going to halve it. So half of 130 is 65. I'll put a line there so I can see them separated. 65 equals 130 E to the minus 0.14 multiplied by T. So you just got to solve that, find out what T is. Should be pretty straightforward. Divide 65 by 130 and you get a half because it is going to halve. So you can actually start with a half equals E to the minus 0.14 T if you're alert. If you're not alert, it's always worth writing it out in full. So we've got this, take logs of both sides, so log a half equals, take a log of an E and you just get the power. So we're going to get minus 0.14 T. We just want T, this is multiplied, so we're going to divide. So log a half divided by minus 0.14 equals T. Now log a half, if you know what log is, log a half is going to be negative. So negative divided by negative is a positive amount of time. Punch that in your calculator and we get 4 0.95 and a whole bunch of decimals, so 4.95 hours. And you could probably leave it like that if you wanted to simplify it. You could write 4 hours 57 minutes, but I'd say they'd accept that. That's nicer, but I couldn't see any reason why that's not correct, and you're done.